So the difference today is you'll see quadratics. So you run into quadratic equations today. Okay, so step number one is we isolate the radical. And then step number two, you're going to take the square of both sides of the equation. Step number three, you're going to set the quadratic that you're going to end up with. You set it equal to 0. And step number four, you're going to factor. So we're going back to factoring today. You're going to factor the quadratic. Okay. And then step number five, we're going to set each factor, each linear factor, equal to 0. And then the last step, this is where you solve. Okay, solve, and you're going to check today. So that's going to be the big difference. Solve and check your solutions. And I'm going to add a note here, because when you check, you may have extraneous solutions. So extraneous solutions are solutions that are not, they are solutions, but when you check, they give you a false statement. Okay, so this will be the key word today. So we might have a solution that it's true, but when you check, gives you a false statement, and you'll understand that once I've gone over the examples. So let's start with number one. So for this one, as you can see, the first step is done because the radical is isolated. So then we move on to step two. So for step two, what I'm going to do is I'm going to take the square of both sides of the equation. So then this gives you the radicand, which is just x plus 9. But then this you take to the side, so you have x plus 7, you have two of them, times x plus 7. Okay, so I'm going to expand this part here. So this is x times x, that's x squared, and then x times 7, that's plus 7x, and then 7 times x, that's another 7x, and last 7 times 7, that's 49. Okay, what I'm going to do next is I'm going to combine like terms. So this x squared is the same, but this 7x and that 7x combined to 14x, and then that 49, we just carry it down. So then we still have x plus 9. Okay, so we are done with simplifying. Next, we're going to set the quadratic equal to 0. So notice we need to move this x to this side. So subtract x and subtract the 9. So we set this equal to 0. So then this becomes 0 equals x squared, 14x minus 1x, 13x, and 49 minus 9, that's equal to 40. Okay, so we're back to factoring here. So what we have to do is we need to find the multiples of a times c. A is 1 and c is 40. So find the multiples of 40 that when you add those multiples, they add to 13. So the multiples of 40 that give you 13 when you add them are 8 times 5. Right? Because 8 times 5 is 40, 8 plus 5 is 13. So then I'm going to factor this quadratic as x plus 5 times x plus 8. Okay, so this we're done factoring. So from here, what you do is you set each factor equal to 0. Okay, so we're in step 5 now. So I have x plus 5 equals 0 and x plus 8 equals 0. When you solve, you just subtract the 5, which means for this one x equals negative 5, and for this one x equals negative 8. But notice that I'm not going to box in my answers because I'm going to check. Okay, I'm going to check to see if any of these two solutions or both solutions are extraneous. So I'm going to check first negative 5. So when x is negative 5, all I have to do is go back to this equation and plug in for x or substitute for x. Okay, so then this is the square root of negative 5 instead of x plus 9. And then is this equal to x is negative 5, and then we have a plus 7 on this side. So negative 5 plus 9 is equal to positive 4. So we have the square root of 4, and this is negative 5 plus 7, that's equal to 2. Then when you take the square root of 4, that gives you 2, which means this is a true statement. So this solution is not extraneous. Okay, so I put a check mark. That means I checked and it gave me a true statement. By the same reasoning, I'm going to check this solution. So check when x is negative 8. So again, go back to the original equation, and whatever you see on x, replace that x with a negative 8. So square root of negative 8 plus 9. Is this equal to, question mark about the equal sign, is this equal to negative 8 plus 7? Well, negative 8 plus 7 inside of the radical gives you a 1. Okay, and negative 8 plus 7, that's negative 1. And the square root of 1 is 1. But this here is a false statement. This is false. So that means that this solution is extraneous. So I'm just going to write ext for extraneous. Okay, so this is the only solution that works. So let's go on to example number 2. The radical is not isolated because there's a minus 3, so I'm going to move that 3 to the other side, meaning I'm going to add it to this side. So then this becomes x plus 3, and this side is the square root of 17 minus x. Then once I have the radical isolated, I'm going to take the square. So I'm going to take the square of this side and also the square of x plus 3. Okay, so then this gives me 17 minus x equals, now I'm going to take this to the side and expand it. So this is x plus 3 times x plus 3. So you'll come to a point in this course that you'll be able to do this without doing the expansion. Okay, so when I multiply x times x, that's x squared, x times 3, that's plus 3x, and then 3 times x, another 3x's, and 3 times 3, that's a positive 9. Okay, so then I'm going to combine like terms. I'm going to keep this as it is for now. So keep the x squared, and then combine 3x and 3x. Those combine to 6x, and then the plus 9, just carry it down. Now we have 17 minus x. We want to have a 0 on this side of the equation. Okay. So then what I need to do is I need to move this 17 to this side. So I'm going to subtract 17 from this side and also 17 from the 9, and add this x to the 6x's. So then this cancels from here. We have 0 equals x squared. 6x plus 1x is 7x. And then 9 minus 17, that's a negative 8. So then we're back to factoring again. So let's find the multiples of negative 8, because a is 1. And those multiples need to be able to add to a positive 7. So the only multiples of 8, negative 8 that give you a positive 7 is when you multiply 8 times 1. But we need a positive 7, so that means the 1 gets a minus. Okay. So let's see. So this factors as 0 equals x minus 1 times x plus 8. Then I'm going to set each factor equals 0. So I'm going to bring this over here for the sake of space. X minus 1 equals 0, and x plus 8 equals 0, which means I just need to add 1. So for this equation, x equals 1, and for this one, subtract the 8. So x equals negative 8. Again, I found the solutions, but I need to check to see if they're extraneous. Okay, so I'm going to go back to the original equation, and I'm going to check the first solution, which is when x is 1. So check when x is 1. So go to this equation, wherever you see an x, replace that x with a 1. So I have the square root of 17 minus 1 minus 3 outside. Is this equal to, question mark, we said what, 1, right? Okay, so this is 17 minus 1. That's the square root of 16. And then we have a minus 3 outside. The square root of 16 is 4. And 4 minus 3 is equal to 1. So then 1 equals 1, which means this is a true statement. So this solution here is not extraneous. Okay, so I check. This one works. But then I got to check this one also. So let's check when x is negative 8. Again, go back to the original equation. So I have 17 inside of the radical. And then instead of x, replace that x with a negative 8. But notice, you're subtracting, right? And this x is negative, so that's a negative 8 inside of that parentheses. And then you have a minus 3 outside. And then is this equal to, x is negative, I'm sorry, x is what, negative 8, right? So negative 8, is this a true statement? We'll find out. So this is 17, this becomes plus. So then 17 plus 8 is 25. And minus 3, is this equal to negative 8? Well, 25, square root of 25 is 5. And 5 minus 3 is equal to 2. And 2 is not equal to negative 8. So this is false, which means this solution is extraneous. So this is the only one that works. Okay, so again, you won't know if the solution is extraneous unless you check. Okay, so that's going to be the difference today. Let's do the last example. Okay, for the last example, I have a plus 3, which I'm going to move to the other side, which means I'm going to subtract 3 from 1. So then this becomes x minus 2, and I have the radical isolated on this side of the equation. So once that is the case, I'm going to take the inverse of the square, of the square root, which is the square. So then this gives me the x by itself, and it's equal to, okay, so I'm going to take this to the side and I'm going to expand it. I forgot to write the square here. So then this is x minus 2 times x minus 2. So then x times x is x squared. X times negative 2, that's minus 2x. Negative 2 times x, another negative 2x. And then negative 2 times negative 2, that's positive 4. Okay, so then I'm going to combine like terms. So I have x equals x squared. Negative 2 and negative 2 combine to negative 4x plus 4. Then I need to get a 0 on this side. I'm going to subtract this x from both sides of the equation. So then I get a 0 on this side. 0 equals x squared minus 4x and 1x combined to 5x plus 4. Okay, so we are done, and this is the quadratic that we need to factor out. So again, let's find the multiples of a is 1, c is 4. So multiples of 4, that when we add those multiples, they add to a negative 5. Well, the only multiples that give you a 5, the only multiples of 4 that give you a 5 are 1 times 4. So 1 times 4, but we need them to add to negative 5 and multiply to positive 4. So that means they both have to be minus. So then 0 equals x minus 4 times x minus 1. Now, don't forget, you can also write this as x minus 1 times x minus 4. Makes no difference. Okay, it's the same thing. So then I'm going to set each factor equal to 0. So x minus 4 equals 0. And x minus 1 equals 0. And when we solve, we just add 4. So then for this one, x equals 4. And for this one, x equals 1. So I am done solving, but I need to go back and check to see if these solutions work at all. So I'm going to check the solutions. So go back to the original equation and check. Let's check when x is 4 first. So then is the square root of 4 plus the 3 outside equal to question mark. X is 4 and plus 1. Okay, so instead of x, 4. Then the square root of 4 is 2. And this becomes 5. And when you combine or add 2 and 3, you do end up getting a 5. So 2 plus 3 gives you a 5. And this is a true statement. So that means this solution is not extraneous because it gave us a true statement. By the same reasoning, go ahead and check this solution. So check when x is equal to 1. So again, go back to the original equation. Square root instead of x, 1 plus 3. Is this equal to 1 plus 1? Well, the square root of 1 is 1. And 1 plus 3 is 4. So as you can see, this is not true. This is a false statement. So then we say that this solution, which means x is equal to 1, is extraneous. So I'm going to box the only one that works. Okay? And that's all for this lesson.